Assalamualaikum and a very good day to both of my panels, Dr. Nur Afifah and Prof. Wan Ahmad Najmi. Hi, my name is IZZATI binti Muhammad ARIF with ID 2018657542, and I'm going to be presenting my final year project titled Effect of Electrical and Thermal Conductivity to a Spot Welded S235 Steel Sheets by Simulation. To start, resistance spot welding techniques have been employed in a variety of sectors for over a century. Over time, the process has evolved into a standard and popular method of combining thin metals such as steel sheet and steel sheet. The spot weld procedure is used not just in manufacturing industries such as automotive, but also in aerospace and also packaging. Spot welding is most commonly used to join parts that are less than 3 mm thick, and it is less effective if the thickness is greater. Basically, to get the greatest outcomes, the spot weld technique was divided into 3 stages, which is squeezing, welding, and cooling. As you can see on the figure, each stages will consist of a few other parameters that need to be defined, which including squeeze time and electrode time at the squeeze phase, weld current and the weld time at the welding phase, and finally the electrode hole time at the cooling phase. On the other hand, electrical and thermal conductivity is one of the most important aspects also in spot welding. As a result of the contact resistance and joule heating, a molten weld nugget forms in the workpieces. Joule heating is the physical action of current passing through an electrical conductor producing thermal energy. When it comes to determining the rate of heat generation and nugget formation, both thermal and electrical contact conductivity are crucial. As a result, as the temperature rises, bulk resistance will rise as well. Hence, when there is sufficient heat generated on the workpiece in resistance spot welding, the creation of the weld nugget will definitely occur. Next, moving on to the problem statement. The purpose of this research is to determine the optimal temperature for weld nugget production in S235 steel material. Because most study is concentrated on other materials such as DP600 and SS304, there is less information available regarding S235 steel. The purpose of this research is to use the MSc MUHAMAD software to simulate the finite element for the spot welding process, as well as to use it as a benchmark or standard or guideline when performing a real resistance spot welding process in the future in order to improve the accuracy of the finite element simulation. Moving on to the methodology. Principally, to model a resistance spot welding in the MSc MUHAMAD have to be through a few other software. The first is a material modeling software, which is named JMAT Pro. In fact, MSc MUHAMAD maintains its own database of materials composition. This list, however, does not include all of the materials. As a result, this JMAT Pro software's function can input and develop new chemical compositions for materials, which are then sent to another piece of software, which is SimFact Welding, for executing other process. SimFact Welding is functioned as a tool for structural welding modeling, calculating distortions and residual stresses based on a mathematical description of related heat sources in their most basic form. The data from SimFact later can be used in MSc MUHAMAD for modeling. If there isn't any data present, MSc MUHAMAD could only model the resistance spot welding without its analysis. In MSc MUHAMAD, the process modeling of the resistance spot welding is quite complicated due to many parameters that need to be defined. The growing need for resistance spot welding techniques to combine multiple materials has matched with an increase in the number of materials made accessible to the industry. The most challenging challenge, however, is selecting and defining the appropriate parameters for each material. Furthermore, subjecting all of the materials to a trial and error resistance spot welding procedure each and every time is likely to be extremely time intensive as well as waste substantial amounts of resources. The FEA simulation of spot welding process in MSc Mark Bantad can be divided into three phases, which is pre-processing, solving, and post-processing, as can be seen on the screen. Among the important parameters that need to be defined are including its materials, contact bodies and interaction, initial and boundary condition, and the load cases before can be run to get the result. After the simulation was completed, the analysis of the temperature can be seen on the model. During resistance spot welding, the surface temperature of the spot weld can be related to the greatest temperature at the nugget center, which can be computed. It is mean that the center of the weld bore the highest temperature. As can be seen on the image, the gradient of the color represents the temperature, which mean that yellow one could be the hottest and the purple one is the coolest. Temperatures between 1300 degrees Celsius and 1500 degrees Celsius are thought to be the ideal for forming a well-formed weld nugget according to theories. In this observation, a temperature of 1400 degrees Celsius was reached, as you can see on the circle point, proving that the correct and appropriate parameters were used to ensure that the weld nugget was produced in an attractive manner. Another aspect that can be observed is the creation of the weld nugget size in relation to the surrounding area. On the basis of theoretical considerations, there should be no difference between size of the weld nugget and the size of the electrode tips, as can be seen on the figure. However, in this finite element analysis, the formation of the weld nugget actually cannot be seen, but the weld nugget formation could be assumed based on the temperature. As example, in the figure, it is assumed that the formation of the weld nugget will start to form when it reaches 1000 degrees Celsius and above. Thus, the gray region showed the temperature of 1000 degrees Celsius. Hence, we assuming the weld nugget has been formed. This is the 3D cross-section of the resistance spot welding simulation. On the basis of the table, it is possible to see the link between the value of the current, the temperature, and the size of the weld nugget. Using current 130 ampere, the weld nugget diameter found is 4 mm when the peak temperature of 1400 degrees Celsius is obtained. It is acceptable to use this value because the size of nugget corresponds to the size of the electrode tip. Next, according to the data in the table, the nugget could not be produced at the specified current of 110 ampere and temperature of 728 degrees Celsius because the melting point of S235 steel should be more than 1000 degrees Celsius. The resistance spot welding process would be unable to be successful unless sufficient heat was generated by the current flowing through the machine. Therefore, it can be concluded that the higher the current, resulting in higher temperature and forming a larger weld nugget. However, if a significant amount of heat is applied, it is possible that the weld nugget will grow bigger than the electrode tip in size as a result of the melting of the sheet material. Based on the contact conductance table of S235 steel, it shows that as the temperature rises, so does the electrical and thermal conductivity of the steel. Heat generation during welding can be affected by the faying area, which can result in a quick rise in interface temperature, which later can lead to the formation of a molten nugget. Every surface of a metal has a thin film on it, which is its own oxidation layer. Thus, if there is an increase in the temperature, the film resistance will decrease and bulk resistance will increase. To summarize, that is another variables that could contribute to the increasing of temperature. Following, the significance of the resistance spot welding is it is a popular welding technology in the automotive industry because it is a low cost but high efficiency means of joining sheet metal. As a result, it may be used with either trained, basic staff or robots because it requires little competence. The bottom line is that the welding process is quick and efficient, resulting in more automobiles produced every shift. Besides automotive, this spot welding also widely utilized in the electronics industry. Circuit boards, gas sensors, and even solar panels are all manufactured using this welding technology. Electronic resistant welding is the name given to this technique, which is also utilized to manufacture sophisticated and sensitive electrical components, varying from cables to switches and hand tools. And finally, the significance of these works is hoped to be able to find a breakthrough for the perfect temperature for the weld nugget formation. As known, there are around 4,000 to 12,000 individual spot welds were used in vehicle assembly, and it is a very enormous amount. When using a resistance spot welding process, the strength of the joint is depending on the weld nugget, and that is why it is important to get a perfect temperature. To summarize this study, the four variables that were monitored throughout the simulation were electrical contact conductivity, thermal conductivity, temperature, and weld nugget size. Based on all the observations, current plays a crucial role because as the current increases, the temperature rises, causing the weld nugget to grow in size. Finally, the contact conductivity must be considered since as the temperature rises, so does the electrical and the thermal conductivity. This is all for my presentation for today. Thank you for taking the time to hear all the result to my research. Any inquiries, feel free to contact me at the number and email listed. Thank you.